Determine the locus of the point P such that the tangent from the point to the circle x squared plus y squared equals to a squared be equal to the perpendicular from the same point to the line lx plus my plus n equals to 0. Let us begin. So here we have a circle. That's it. The circle has the equation x squared plus y squared equals to a squared. Now clearly the circle is going to be centered at the origin and it's going to have a radius of a units. We're going to consider a point P. Let's say P has the coordinates x1 comma y1. Now the tangent drawn from the point P to the circle meets the circle, let's say at point A. Fine. There's a formula to find out the length of the tangent. We'll come to that in a moment. Now we have another straight line. So let's say this is the straight line, but the equation L times x plus m times y plus n equals to 0. Now the perpendicular distance, let's drop a perpendicular from point P onto the line. Let's say it meets the line at B. Now this perpendicular distance PB is going to be equals to the length of the tangent PA. Now using this information we need to find out the locus of the point P. Let us begin. So here we will start with the given equation of the circle. So we have x squared plus y squared equals to a squared, but we'll transpose a squared to the left hand side. This will be equals to 0. Now we're going to compare it with the general equation of a circle, which is given by x squared plus y squared plus 2 times gx plus 2 times fy plus c equals to 0. So we get the value of 2g. So 2g will be equals to 0. 2f will be equals to 0 as well, and c value will be equals to negative a squared. The reason we're trying to find out the value of 2g, 2f and c, because the length of the tangent PA from the point P will be given by the square root of x1 squared plus y1 squared plus 2gx1 plus 2fy1 plus c. So we'll substitute these values. We're going to get the square root of x1 squared plus y1 squared. Now 2g and 2f are 0, so we're only left with plus c. And now since c is negative a squared, we have negative a squared. This is going to be the length of the tangent from point P to the circle. We're going to label this as number 1. Next, we'll try to find out the length of the perpendicular distance PB. Now there's a standard formula for finding out the perpendicular distance of a point from a straight line. All we need is the coordinates of that point P, which is going to be x1 comma y1, and we need the equation of the straight line. Both of them are available to us. So what we'll do, we'll take a ratio. Now here we'll start with the coefficient of x of the straight line, that's L. L will get multiplied with the x coordinate of the point P, so that's x1. Added to coefficient of y of the straight line, so that's m. M gets multiplied to the y coordinate of point P, so that's y1. To it we are going to add the constant term of the line, so that's n, divided by the square root of, now inside the square root we're going to consider the coefficient of x and coefficient of y. We're going to square them and add them to each other. That means we're going to get L squared plus m squared. So let this be equation number 2. Now according to the problem, it's given here that the length of PA is given to us, that PA is equals to PB. So let's equate them. So PA, we have square root of x1 squared plus y1 squared minus a squared. This will be equals to the length of PB, the perpendicular distance. We have Lx1 plus my1 plus n whole divided by the square root of L squared plus m squared. Now we're going to square both sides to get x1 squared plus y1 squared minus a squared. So this will be equals to Lx1 plus m times y1 plus n whole squared divided by L squared plus m squared. Let's cross multiply. Cross multiplying gives us L squared plus m squared multiplied to x1 squared plus y1 squared minus a squared equals to L times x1 plus m times y1 plus n whole squared. Now we do the final adjustment. Since we want to find out the locus of the point P, all we have to do is replace the value of x1 with x and the value of y1 with y. So that's going to give us the final equation of the locus of the point P. So we have L squared plus M squared multiplied to X squared plus Y squared minus A squared. This will be equals to L times X plus M times Y plus N whole squared. Thus, this will be the locus of the point P, such that the length of the tangent from the point to the circle and will be equals to the perpendicular distance from the point P to the line Lx plus My plus N equals 0.